Hooray. So it says we're live.
Hello.
I'm
Are
going
we
to
live?
chat. Hello.
Hello, everyone.
It says,
I don't see us. Oh, yeah, there we are. All right.
do you see us on the
I think we're live.
Okay.
And we have a few people. Hi, everybody.
Hello. It takes a few minutes to get things
Yeah.
rolling.
Technology. I see some people saying hi.
Yeah.
Jugan, Gilmar, Adriana, Rolf, and
We had a few technical difficulties getting the live stream connected, so I'm like, is it actually working? I don't know, but it looks
yep.
like it is. I'm seeing some stuff in the chat that suggests
Yeah,
it's working.
it worked out. I'm very happy to hear that.
Yeah.
Yeah. Cool. So, how are you doing, Josh?
I'm doing great. How are you doing? You just got back from a
Pretty good.
sweet vacation.
Yeah, it was fun. I was in Europe for a bit. And you got back from some interesting trips, right?
Yeah, I was
You
in.
did.
I guess the last time we did the live stream was in July. So
It's been
it's
a
been a
while.
while. So
And
I've
then we did one
since.
with Jay.
What's that?
Yeah, we did one with Jay. I
Is either
think it's
June or July.
July,
It's been a few
something like
months.
that.
I've
Yeah.
since traveled to India
Really?
to talk at the Data Hack Summit 2024.
Wow, that's nice.
And then I went to Brazil, Sao Paulo, to talk at Santander. And
Okay,
that both trips were absolutely fantastic.
that's awesome.
But it's good to be home, and it's good to be live streaming again. It's good to be
Yeah,
hanging out with Lewis.
yeah. I always like hanging out with Josh, so this is wonderful.
I think I'm not certain. I think we're both going to be at that uphill conference
In Switzerland.
in Switzerland.
Yes,
Yeah. So
2025.
so I'm excited about that because if nothing else happens between now and then, I know I'll at least get to see you then in
I
person.
I think so. Yeah, definitely.
I
That's exciting because we
we
never
could
never met in person. We talked a lot
I
online, but
know,
never in
and
person.
maybe
So
when we're there or whenever we meet up, we can do a live stream, but we can be together instead of being separate. We can do
that would be cool.
a little
Yeah, yeah,
event
yeah.
or
We'll
something.
just live stream from the same camera.
Yeah,
Yeah, that's very exciting.
yeah.
Yeah, let's see who's around. So who wants to tell us in the chat where they're coming from? And I'll read that where they are, and I'll just read them. I see
It looks
Jose
like
is
we
from
got someone
Venezuela.
from Venezuela, which is
Hola,
cool.
Jose.
Hola.
A neighbor. I'm from Colombia, right there. Yeah. Well, we can start. I see some questions there.
Yeah.
So we have three things today for the audience, and more if we want. We have a few questions that were in the live stream that we're gonna answer, mostly about learning, machine learning, uh, fields to work on, etc. Then we want to talk about this recent news about the physics Nobel Prize, which
That's
was
right.
won by Jeff Hinton and John Hopfield, AI people, which is very exciting.
Oh,
And it's huge for AI. I never thought I was gonna say something is huge for AI, but this is huge for AI.
that's
And then,
true.
last but definitely not least, we're gonna talk about your book, which is
Ah,
wonderful.
yeah. Right.
I got the chance to see it, and I really like it. So for people in the audience, this is a wonderful wonderful book.
That's right.
We have people from New York City, Armenia, Hungary, Saudi Arabia, Ireland. I love it. People
Yeah, I
all over the
do.
world. Um, I mean, let's dive into some questions. And by the way, people can always put questions in the chat, and we'll if they're easy, we'll get to them. I'm kidding. We'll get to them. Whether we answer them correctly or not, we'll definitely answer them. No, definitely put questions in the chat,
Yeah.
and um, we'll get to them. But let's start with the ones that were put in the previous chat. So let me ask you one.
Yeah.
If you got stuck in learning, what methods do you follow to break the problem and understand it?
Yeah. So, and this happens to me all the time. So I'm actually very well practiced in what to do when you get stuck. Um, and what I always do is if it's like a topic I'm trying to learn something about, I try to read uh, everything I can about whatever that topic is. And to be honest, what that means is basically skimming through stuff and not understanding any of it. Um, uh, uh, Usually the doc, say like I'm trying to learn about how PCA works, and I'll read Stack Exchange posts because there's lots of people asking about it there, and there's people explaining it. But I also read manuscripts, um, and I'll read the Wikipedia article and all that stuff. And a lot of that time, I don't understand anything that I've anything from any of that stuff. And what happens though is I start seeing words that are used in all of these different publications. On the Wikipedia page, they might reference some terminology. There might in the manuscripts they may reference similar terms, and I kind of build up a little bit of a histogram in my brain of words that I've never seen before. And then it sort of becomes that rabbit hole where once I see what terms they're using in this field, I'll start diving into those individual terms, and those terms lead to other terms which lead to other terms. So it's just like a like a landslide of terminology, finally trying to get to the bottom of something where I finally understand things. And even then I might get to the bottom where there's no longer any new terminology and I don't understand it. So what do? I just keep reading it and rereading it, and this takes time. It takes a couple of days, and sooner or later, one little bit makes sense. One little tiny bit, and then with that, it's almost like it's like a little finger hold on a cliff, and I can get my finger in there and I can hold my weight, and then and that just lets me reach up, and eventually I'm climbing, and I get back out of this deep cave of terminology, and I bubble up to the top, and usually then I can sort of read those top level articles. But then what I'll do is I'll start looking at code. I'll look at implementations, um, and then I'll start trying to either code it myself or I'll use somebody else's implementation, and I'll see if the input and the output makes sense the way I expect it. Usually it doesn't. Usually I'm completely wrong in my understanding at this stage. But then I can start trying to reconcile the difference between what I'm seeing with the implementation and what I thought I understood from the documentation.
Mm-hmm.
And then, sooner or later things start coming together. But it's one of these things where um, the real key is just don't give up.
Mm-hmm.
There's so many, the first couple of weeks of this process is nothing but failure. And sometimes it goes on longer than that. Hopefully it's not too much longer, but it can go for a while.
Mm-hmm.
And I just don't ever give up because I know fundamentally a lot of the math is just simple math. It's multiplication, it's addition, it's
Mm-hmm.
division. If the
Yeah.
things get really funky, they may take a log and they may take a square root. But it's fundamentally small pieces that I know I understand,
Yeah.
and it's just a function of getting to that level and then building back up to the top.
Yeah.
Yeah, so that's my
No,
story.
that's definitely a good answer. Yeah, I have done something similar, and I feel you
Yeah,
mentioned something which is kind of like being stuck.
yeah,
I feel like the day I made being stuck my comfort zone, my life got a lot better. Because before I
yeah,
hated being stuck, and now I say just no.
yeah,
I'm gonna be stuck, and I feel like when I read any paper or anything, I understand nothing. Even if it's stuff I already know. As a matter of fact, even if it's stuff written in the past, like papers I wrote in the past, I don't understand them because they're
yeah,
written in weird language of formulas, and I can't do formulas. Never. And so my trick that I would add to what you said is picking a super simple example. So if it's imaging, for example, two by two monochromatic. Four numbers between 0 and 1 is an image, and I try to work everything out there. So I do all the formulas in those numbers. If it's text, I try to have a language with 4 words and a sentence with 4 words,
yeah,
and try to do that, or a matrix of 2 by 2. Like I always try to work out all the formulas there, And then
Yep.
it turns out that it's always sums, as you said, sums and products, and logarithms that only appear to turn a product into a sum. That's the reason they appear, right? So like it's always, I have a few tricks, but always just trying to get the simplest example. And I've talked a lot. ChatGPT has been super helpful because now I before I used to bug my friends. I bug people, like I ask them questions and stuff, like expert people I know. But I now just ask ChatGPT, and I obviously if you ask it right away, it gives you the formulas and the same thing you find in Wikipedia, right? But now I just said, okay, no, but I want an example with a dog and a cat, and I want this or an image that is 2 by 2 or something. Help me understand this, and it's actually like after a while it starts getting understanding what you want. And so yeah, but definitely just trying and trying. And I feel like I throw a lot of information in my brain and hope that it organizes it. So I
Yeah.
watch a little bit of a video, I read a little bit of a paper, I scribble a little bit, then I forget it, I come back, and I don't have an organized way of learning. But I feel like if you just kind of throw stuff, eventually starts clicking, and sometimes things take years to click.
Yep. Yep.
So now I just hope it clicks before the algorithm goes out of fashion, because
Yeah.
if I understand something old now, like it doesn't help. So I now we have
Yeah.
deadlines. But yeah,
Yeah.
speaking of that, what are the hardest topics you've explained and why? That's another question we have.
Oh man. I'll be honest. So my PCA video took at least a year to make. That was really hard for me. Um, and it's one of those things like once I made the video, it's like, oh, this is obvious. But you know, getting to that stage was really challenging for me. What else has been really hard? Logistic regression took forever.
Mm-hmm.
Um, neural networks was interesting. It was interesting in a weird way in that um, I'm a big fan of Three Blue One Brown. He makes
Yeah,
incredible, great
great,
content, and I
great guy.
remember watching his videos on neural networks and being like, "Oh, these are awesome. Why would anyone need to do another video?" And on neural networks, and so I wouldn't even think about neural networks for a long time, and then someone posted a comment on one of my videos that said, "You should do a video on neural network," and I wrote back and I said, why? Check out these videos by Three Blue One Brown. I sent him the link, and the guy wrote back and he says, "I've seen those before. You still need to make a video because I don't really get it." And so what made this hard is I was like, well, what else is there to say? And so I watched what Three Blue One Brown did. I watched those videos again, and again they were fantastic videos. And so but I was like, but clearly there's something missing that this viewer wants.
Mm-hmm.
So I had to watch those videos and go, I see what he's saying. I see what he's illustrating. What's he not illustrating?
Mm-hmm.
What's missing? And I had to think of what was missing.
Yeah,
And and that was hard for me to
yeah,
figure out what wasn't in there. And that was, but I eventually figured it out. I eventually figured out what Three Blue One Brown wasn't doing, although he was doing a lot of things right.
mm-hmm.
What he was, and I'm not saying he was doing anything wrong either. Like he was just doing it the way he did it, right? Um, but what wasn't there was just like what Lewis was saying, like a super simple example where he could walk through and
Mm-hmm.
see the math in action without it
Mm-hmm.
being really abstract. You can actually do the multiplication, actually do the addition, and then plot a point on a graph and say, uh, based on the input value, which is on the x-axis, this is what the output value is so far, and you can plot that on the y-axis. And once I started doing it that way, where you could see how the neural network is transforming the input into the desired output, you could actually see it happen one step at a time, and it wasn't like abstracted into sort of generalized equations, but actually we were doing the math one step at a time and
Mm-hmm.
actually coming up with real values.
Yeah,
And all of a sudden I was like, oh, that's how I'm going to do this, and I'm going to, but it took me a while to figure that out as well, like
yeah.
to come up with a new way to point out something that hasn't been seen before.
Yeah, definitely. I feel like with neural networks, I had something similar because I was looking at them for a while and I was obsessed with the XOR example, right? The one that's like this is a positive, positive, negative, negative, and you can't cut them with a line. Because I was trying to look for something that you can't cut with a line, because
Yeah.
that requires a neural network.
Yeah.
I saw some blog post by Chris Ola where he bends space in a weird way, and I thought that's gotta be something. I
Yeah.
remember looking at it for months and months and months until one day finally something clicked, which is if I have, for example, one logistic regression, that's a line that splits the plane in two.
Yeah.
And if I have another logistic regression, that's another line that splits the plane in two. And if I overimpose them, then I have two lines that split the plane in four. And now I could use those four regions, and maybe one of those four regions is where I want my data to be, right?
Yeah.
And so when I started looking at overimposing, I think there's something called neural network TensorFlow playground where you can play with them, and you overimpose the regions, and then you joining lines, you can start getting any kind of curve you want.
Yeah.
That's when they finally clicked.
Yeah.
And then yeah, so that one took a while. Another one that took a while was reinforcement learning. I feel like I took a long time learning, understanding that. So much that I was once teaching a class in university on 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 machine learning, and I had reinforcement learning as the last lecture, hoping that I would understand it, and then I kind of had to like remove it without anyone noticing because I couldn't really click it my own way,
Yeah.
and it took more years until one day it finally clicked. I feel like that's one that took a long time to click.
Yeah. Yeah.
Uh, and then yeah, a few other topics. Quantum computing took some time. I feel like I have a
You
few
just had some
videos
new
coming.
videos on quantum computing.
I have some videos and I'm dropping one pretty soon. It's not. It's kind of like starting. I'm like the preview of quantum computing, so I'm doing Fourier transform, fast Fourier transform, and then I'm gonna get to the quantum Fourier transform. So I'm still understanding it, but
S-
fast Fourier transform is my next video coming out
That's
soon.
awesome.
Yeah,
That's
yeah, yeah.
exciting. So
Uh,
yeah, if you don't subscribe to Lewis, make sure you do that
Subscribe to
because
Lewis. Yes, I'll put it in the.
yeah, yeah.
Yeah, yeah,
Oh
yeah.
yeah, we can put that in the chat. Holy
Let's
smokes.
put in the chat. Yeah, let me put it in
Do
the
it right
chat.
now.
Uh,
Can you
oh, I see a lot of questions.
I know we got all kinds of good stuff
Okay,
filling
let's
up
let's
here.
go through. We have two more here that are quick. How do you understood it? How do you know you've understood a topic thoroughly, or you still need to dig more?
Yeah, I feel like there's like a little elf on my shoulder or a little tiny person or whatever that's uh, like I well, okay. There's a couple of ways to do this. One is the elf just tells me I'm stupid all the time,
You got the same elf as me.
and, and that like you don't actually know what you're talking about. So there's a lot of like anxiety and sort of like what is it like imposter syndrome going on right
Oh,
there.
all the
Like
time.
the guy's like you don't really understand it, and that does push me to try harder to learn more. And like I have to like then convince the elf. I'm like, no, I do. And the elf is like, well, what about this situation? I'm like, okay, you're right. I've got to go back and figure out that one situation. Um, and but but also, I know I'm getting close when I can use the implementation of whatever algorithm I'm interested in teaching or learning about. And the input gives me the exact output that I expect, right? And I can look at all the things that happen in between. And I go,
Yeah.
yeah, this is all exactly as expected. And I can throw in more complicated things, and I can really predict what's going to happen. So that's a good sign that I'm at least in the ballpark of understanding. But the other thing is when I'm building the presentation, when I'm making the slides for the StatQuest video, I read it out loud, and when I read it out loud, it's almost like I'm talking to that little elf on my shoulder, and I can notice that there's like jumps. I don't know, somehow that when I'm reading it in my head, I don't notice the jumps. But when I read it out loud, I'll realize that I'm going from one concept to the next without talking about all the little important things that are in between. And that'll go like, well, what is going on in between those two things? And when something about saying it out loud points these gaps out to me, and then I have to dive in and I have to figure out those gaps. And when I can finally get to the point where I can read through all the slides out loud, and I feel like there's a smooth transition, there's no jumps in logic, there's no like all the steps are baby steps instead of there being like, and then we start from point A and then we end up all the
Yeah.
way over here.
Mhm.
And something about reading it out loud forces me to think in terms of baby steps.
Mhm.
And so that's how I do it. What about you, Lewis? I'm curious what your strategy
I
is.
have the same elf. Yeah.
Yeah.
No, I feel the same. I have a superpower, which I never know it was a superpower, but it's I don't understand anything. So like I'm
Yeah.
very slow at
Yeah.
understanding. Like if I'm in a talk, look at my face. If you ever see me in a talk, and I'm like, I really have a hard time understanding stuff,
Yeah.
which I found out later in life that is good for me when you explain stuff.
Yeah.
But I find that if I'm not understanding, it's possible that I'm not understanding my own explanation.
Yeah.
So if my explanation contains math and formulas and matrices and I know it's true. I trust it. I see the steps and I believe it, but I don't understand it.
Yeah.
And there's a moment where I feel happy. And I don't know how to describe it, but I just feel happy. I think is when I've removed all the formulas. If
Yeah.
I manage to remove everything and have an example with little people or something, or cats and dogs or cows or something like apples and oranges. If I manage to do that and have it fully geometric, fully visual, then I'm happy about it. And there's a moment where I clicks and I go, finally, and I just have a few seconds of awe and celebration, and then I start, then I start making the video. But I feel like it helps me that I'm so bad at understanding abstraction and technicalities that when it clicks, it has to be super simple. So yeah,
Yes.
yeah. Great. There's another question here, and I think I see a lot in the chat, so I think we can get through those. But with so many fields and technologies, it's hard to cover them all. Which field of AI should I focus on to get a job? Computer vision, time series, LLMs, reinforcement learning, etc. It's a good question.
Yeah, that is a great question. And I don't, to be honest, I don't know if I have a great answer for that. I just know what my personal preference is, and it works for me. Um, so there's a lot going on right now, and it's good to have at least a small part of your brain following that, right? Make sure you're comfortable with ChatGPT. Lewis is a lot more comfortable with it than I am, but make sure you're at least mildly comfortable with using AI, using sort of whatever the latest tools are, just a little bit. You don't have to understand all the details, but you don't want to like completely fall behind in that area. But what I would spend most of your brain working on is, and this is going to sound ridiculous, but the things that have been around forever, like the linear regressions, the logistic regressions. These tools have been around forever, and to believe it or not, they're not going anywhere. And they can actually be incorporate, like even with the latest greatest AI, you can incorporate a logistic regression using the variables generated by an encoder only transformer to do classifications. These tools have been around for a long time and they're not going anywhere. They'll still be in fashion, and one of the reasons why they'll be in fashion is they're very explainable. They're and certain industries, like for example, banking. That's all you can use. You actually can't use sort of the most modern technology out there. And so these tried and true methods, have a place and there's like careers out there waiting for you to use those methods because, and they've been there forever and they're not going anywhere because they're efficient. You can, like any kind of regression model, linear or logistic, whatever you're using, computation time is like zero, right? So they're super efficient, but also super explainable, and you can tell exactly what each variable is doing and how it's contributing to the output. And in certain industries, that's critical. And so I'm a big fan of just making sure you understand the basics, rather than sort of like jumping to the top and being like, I'm gonna become an AI master without any of the foundational work. So that's
Yeah.
I don't know if that's the best answer for everybody, but that's just my personal bias and my preference.
Yeah. I think very similarly. I feel like, I mean, one thing is that transferability is not that hard. I feel like a lot of people, when LLMs became the thing, a lot of people came from, including me, other places in AI and moved there because the ideas are very similar. And if you're comfortable, as you said, with the basics, like if you know what a neural network is, that gets you into anywhere because right now
Yeah.
all the advances are some different neural network. Maybe they'll change,
Yeah.
but as of right now, if you fully understand a neural network
Yeah.
and maybe how they work for images and how they work for text and like maybe the idea of a convolutional one, a recurrent one, even though they're not so much used right now, but
Yeah.
those ideas, if you understand that and have trained models and how to evaluate models, like it's all that,
Yeah.
right? And so if something new comes tomorrow in imaging or video or something, a lot of people can just switch there if they understand the stuff solidly. It's always the same algorithms. I feel like it's like sports, right? Like if you have a good physical state, like if you some things like running you can just do and that'll help you in all the sports, right? Going to the gym helps you in all the sports.
Yeah.
And then if you're doing soccer and then want to switch to basketball, if you're a good athlete you can. Not if you're in the NBA you can switch to go to the World Cup, but we're not talking about that. We're talking
Yeah.
about like do you play soccer for fun, then you go play basketball for fun. I feel like it's the same with AI. And so I tell people to follow what they like the most. Don't get stuck in one algorithm, but like try to have an open mind, but like follow what you like. If you love working with language, just go for it. But if you love images, just go work on that. And if reinforcement learning it's what you like because you want to use robots or make them play some game or something, like go for whatever you love because that's really where you have infinite supply of energy.
Yeah.
And then just keep an eye on the market, but don't panic. I think that people panic, and it's easy to panic because not many fields are as fast moving and
Yeah.
wide as AI, and it's so easy to not to look at all the stuff you don't know. I mean, every
Yeah.
day I open LinkedIn and an area has stupid AI because I'm like I don't know a lot of all this stuff people are talking about. But then you realize, you're a few steps from knowing that if you know other similar stuff, and you
Yeah.
don't need to know all the stuff.
Yeah.
So yeah, pretty much that. Don't panic.
I think that's great. Just in summary, don't panic.
Don't panic.
And I like
Everybody else is just as panic.
yeah, exactly. Everybody's freaking out. I also like the advice of like just chase things you're really interested in as well, because that's where you're going to have most of your energy and most
Yeah.
of your patience and endurance and all the things that are going to help you understand it.
Yeah.
Yeah, I think those are some great bits of advice.
Yeah. Definitely. All right, we are at a fork in the road. We see a bunch of questions.
Yeah,
Uh, we're at about halfway point, so we
yeah.
could. You want to talk a bit? Why don't we talk about your book? Why don't you tell us a bit about an illustrated guide in neural
Yeah.
networks, which I
I
think
have
is great.
yeah, so I have I've got a book coming out in very early 2025. Um it's called the StatQuest Illustrated Guide to Neural Networks and AI, and it goes from the most basic neural network all the way up to almost the state of the art, maybe the state of the art. Sort of
Exactly.
depends on where we are. Lewis is one of my technical editors,
I loved it.
and so he got early access so he could find out all the mistakes. And I've got a handful of people doing that, finding little errors and little typos, and also like conceptual things where, when you're typing, when you're writing a book, I hate to like maybe like um, I guess it's anything is a draft, right? When you first write or do anything, create anything, it's always a little rougher around the edges, and sometimes I maybe things needed to be clarified, or maybe I overlooked things, and so people like Lewis are helping me like fill in all those gaps because it's all at a point where I can't really see the mistakes anymore because even if I know that it would be a mistake, I just can't see it on the page because my brain automatically fills that gap. And so that is super exciting, but we've got a little bit of editing to do. I'm going to spend the rest of the month going through Lewis's edits and a bunch of others. And then we're going to send it to what's called a copy editor who's going to make sure that the grammar is correct. And after that, I think we're going to have it out. I know some professors are already assigning it for their spring semester classes. So I kind
Nice.
of have a deadline. We got to make this happen.
You
Um,
gotta make it.
so um, so that's that. That's the book. I know I haven't seen a question about it and I know we've got tons of questions in the chat, and we will get to those. But I do want to address the Nobel Prize.
The Nobel Prize.
Lewis, do you have thoughts about this? Especially the one that went out for physics.
I don't know. I'm not a physicist, but I think having a physics prize going to an AI person. It's big, and I don't know what the physicists are thinking. I mean, I'm definitely
Well,
excited.
I read I was on Ars Technica and I read the comments on that, and they were I mean, not everyone, but so many people were so bent out of shape about this.
Yeah.
They just felt like they were like, this is just hype. This is, they're just getting on the AI bandwagon. Why did they, people were just bent out of shape over this. And I actually have got some thoughts about this because I spent about 14 years of my life as a geneticist.
Uh huh.
And so I used to pay very close attention to what was going on in medicine and physiology and sort of biology and these things. Physics was always sort of like obscure, random, weird stuff. But the Nobel Prize in uh, medicine and physiology, and I guess I don't know if there's a biology one or maybe that's the medicine one. Um, Often would go to someone or a group of people that did not necessarily find something that gave us fundamental understanding of how the human brain worked or how the human heart worked, but they'd come up with a method that then allowed other people to to go crazy with their research that was then profoundly changed the field. A good example is a method called polymerase chain reaction. It's called PCR for short. This was something, I don't know if you remember, but you used to have to get COVID tests, right? And the PCR test was more accurate than
Yeah.
the antibody test. And so PCR became something that was critical for making good COVID tests. But within the lab, anyone who's doing any kind of genetics research uses this method of PCR, polymerase chain reaction, and it's like used daily in almost every lab in the whole world. And it the method itself was not like didn't provide a whole lot of insight, on how the biology works. They already knew. They just had to put the pieces together to make it work, and that got them a Nobel Prize. There's another thing called green fluorescent protein, which is a jellyfish protein that someone's like, hey, I can put this in a mouse and I can make their kidneys glow, or I can make cells that are expressing this gene glow green. And that makes it easier for me to study this disease. It didn't help me. It didn't on its own. It didn't shed light on the disease or on the function of the heart or any of these things. But it made it easier to study those diseases. And again, that got a Nobel Prize. This guy Oliver Smithies, a guy I used to work with, he got a Nobel Prize for a method called homologous recombination that was known how it worked, but he was able to co-opt it into inserting pieces of DNA. And so then again, it's another method to help people understand biology. And so in biology, I know I've been rambling for forever, but in biology, the examples I just want to give you is that time and time again, the Nobel Prize goes to someone not for necessarily finding some groundbreaking function of like how the brain works, but more they came up with a way to facilitate researchers in general and expedite and rapidly speed up the time we go from general hypothesis to testing that hypothesis to making conclusions and publishing new insights into how biology works. And I feel like this is the first time that's happened in physics, right? Because
Yeah.
neural networks are used for image classifications, like these not satellite, excuse me, these radio telescopes. They generate so much data all the time, and most of that stuff is basically run as a preliminary sort of like low pass filter on the data. They put a neural network on there to identify things that are interesting, identify outliers, identify stars, classify things. all that stuff is run through neural networks, and it's a way of just like dealing with the flood of information that we can now generate on a huge scale. And all branches of physics are becoming like this, where instead of like one measurement, they generate tons and tons of measurement. And to wade through that, a lot of people are using neural networks to do that. And I feel like, so what they've got now is they've got someone who's created a method that is now sort of permeated physics, and it helps pretty much everyone do physics better and faster to get more cool results. And so the first time ever that's happened in physics, and people are getting all bent out of shape because the neural network doesn't give us some profound insight onto like the small force of an atom or something like that. But it just makes all of physics easier to do. And more practical. And in biology, we've been doing that for years and years and years and years. So it was no surprise to me. But in physics, I guess it's new for them. And so there's like a cultural shift in terms of like, what does the Nobel Prize mean?
Yeah.
But hopefully they'll get with the program.
Yeah, I mean, I feel like, yeah, there's definitely disciplines. I feel like science should be like all the disciplines
Yeah.
together. Like we put artificial walls between them that
Yeah.
only create division because it's hard to, sometimes even I'm a mathematician, and even inside math, you're like, oh no, that's a different topic than me. I
Yeah.
don't need to touch that, or that's physics, or that's science. So I feel like it's good to unite them. But there's an ego that some disciplines have, and I think it's hard when someone from a different field
Yeah.
wins it. And in particular, the Nobel Prizes have a bias. It's not a bad thing, but it have a bias of being like scientifically useful, like being. You can't just come up with a theory, and so many great people have not won a Nobel Prize because they came up with just a theory,
Yeah.
right? Like that maybe was proved experimentally much later. Like Hawking didn't win a Nobel Prize. Maybe in many years, they will prove something experimentally about black holes when we're able to
Yeah.
get close or something. But right now, it's just theory.
Yeah.
Nobel prizes have that bias, which is why there's no Nobel Prize in mathematics, for example. People in math are always, wondering why there was never a prize for mathematics, and it's because, yeah, by the time when you create a mathematical theory, if it gets used, by the time it gets used, it could be 400, 500 years, like calculus, right? Like it got used much later. So are you
Yeah.
going to give a Nobel Prize they will all be posthumously.
Yeah.
So yeah, but I think this one, yeah, and I mean, as I said, I'm not a physicist, so I don't know.
Yeah.
I did see one time in math, the Fields Medal was given to a physicist, Edward Witten, and even himself, like he's amazing, like he's very quantum field theory and a bunch of really complicated stuff. But even himself would say, like, I didn't prove anything; I just created conjectures. And mathematics has a thing for proving, right? You have to prove something and prove. But many times finding the conjecture is much harder, right? Like thinking, oh, this could be true. I don't know how to prove it, but this could be true. So I think it enriches fields. But yeah, this one was kind of like I think it's using, I don't know, they used physics ideas to create neural networks, right?
Yeah.
Because these are basically they use statistical mechanics and a bunch of energy things to train neural networks. So I think the genius is there. They didn't create any new theories, which is, what probably, what probably makes people wonder why they got it. But I think they managed to use some stuff pretty well.
Um,
Yeah.
Can I do a little shameless promotion? Lewis actually has a video on the Boltzmann machines
Thank you.
that these guys,
Very kind of you.
part of the award was given for. So if you want to learn about, and I kind of want to
Yeah.
learn about these Boltzmann machines myself.
Absolutely. Let me put the
And so
link
I'll
here.
be watching this video later this afternoon. But do check out his video on these things if you're at all curious as to sort of like how these things actually work and sort of what the award was.
Thank you so much for the promotion. I think it's definitely not shameless if you do it for someone
Oh,
else
that's
out
true.
of the kindness of your heart. And I have so this video was kind of flat. It wasn't getting so many views because it's not a topic that everybody cares about. But I started getting a lot of views a couple of days ago, and I'm like, oh, what happened? And then I realized the Nobel Prize. So I'm making one on Hopfield networks next, and I just just understood them yesterday. I can give you a a preview. Do you
Oh
want
yeah,
a tiny preview?
yeah.
Okay,
Give us a
so
tiny preview.
this is Hopfield networks. Okay,
Yeah.
check it out. I'm gonna give you a data set, a small data set,
Yeah.
and you learn it. Okay, it's very easy. It's bit strings of length 2, so zeros and ones, but only 2 of them. Here's the
Yeah.
data set: 0 0. That's the first one.
Yeah.
0 0, 0 0, 1 1, 1 1, 1 1. Okay. That's the data set. Now I'm not gonna ask you for the data set. Let's pretend it's so big that
Yeah.
you couldn't store it in your head. Can you
Got
give
it.
me a random element from that data set?
0 0.
There you go. 0 0. You didn't say 0 1
No.
because why? What was the special about the 0 0? Why did you say that?
I think you said it a couple times.
Yeah.
Yeah.
I said 0 0 and you remembered one thing, which is that
Yeah.
it's the same number, right?
Yeah.
Like
Yeah.
whatever the first one is, the second one also is.
That's right.
So you remember one thing, that they're correlated.
Yeah.
Pretty much 100% correlated.
Yeah.
So I gave you 12 bits. I gave you 6 bit strings. I gave you a lot of information, and you remembered one.
Yeah.
That's a Hopfield network, right? So you remember this. There's a node. If I
Yeah.
this is a way to put it physically. There's a
Yeah.
node. Sorry, pictorially. There's a node
Yeah.
here for the first bit. There's a node here for the second bit, and there's a strong correlation edge between them, like
Yes.
with a label 10 or 100.
Yeah.
Now, if I were to give you this data set, 0 1, 0 1, 0 1, 1 0, 1 0, 1 0, right?
Yeah.
Then
Yeah.
it's the opposite. They're inversely correlated. So it's a
Yeah.
node here, and a really negative edge.
Got it. Bam.
That's it.
Yeah.
Bam. Oh,
That's
I got
a
a bam.
Yeah,
Woo!
we got a
I
bam
love
in the
it.
comments.
We
too.
got a
Someone-
bam. I'm honored.
I
So
love
for
it.
example, let's say I give you bit strings of length 10.
Yeah.
And I give you 1 trillion of them, and you're like, well, this is way too much. But you
Yeah.
start noticing that the 2 first are correlated, and the first
Yeah.
and the 7th are correlated,
Yeah.
and you create a net graph
Yeah.
with 10 edges. Sorry,
Yeah.
10 vertices, roughly 10 squared edges. So it's
Yeah.
100 parameters, 90 really, but
Yeah.
to remember your trillion things. And then if I ask you for a random point in that data set, you can sort of pick out from the graph a random element. There's a
Yeah.
way to pick it up. And that's it. And it's
Yeah.
not even, this is the interesting thing. It's not a neural network that you train like a neural network by slowly adding epsilon. No, you just take a dot product of vectors and add it, and you get the labels. It's deterministic. It's completely deterministic.
Yeah.
Now, here's the thing. Let's say that there's triple correlations or quadruple correlations, right? Like let's say the first 2 are 0, then the 10th one is 1.
Yeah.
That's harder to pick up.
Yeah.
Then you need an RBM. So an RBM, a restricted Boltzmann machine, which is now we're going to Hinton's territory, right? Like Hopfield was now Hinton. So you have 10 nodes, let's say 10 nodes, and a bunch of hidden nodes that connect
Yeah.
to all of them, creating bigger correlations. So if you want to create a correlation between the first, the second, and the 10th, you have a node here that has a big edge with 1, a big edge with 2, and a big edge with 10,
Yeah.
and small edges with the rest. And you can create correlations like that. So an RBM does train like a neural network. It's much bigger space. It's a much harder space. This one does train with a learning algorithm that like may get into a local minima, blah, blah, blah. All the stuff you can learn from your book, by the way, if you're a local minima. And so that's pretty much it. So the RBM video's out there from a while ago, and the Hopfield network is coming in pretty soon.
Cool. Double bam. Yeah, we got a double bam. That's exactly
I got
right.
a double bam. I love it. Thank you very much. Thank you very much.
Yeah.
Cool.
Well, how about we dive through some of these
Let's dive.
questions in the comments?
Yeah.
I see one really easy one.
Go for it.
So I'm just going to go for it. Someone says, the field moves really fast and it feels overwhelming. How do you not get overwhelmed? And part of that, earlier, I don't know if you heard Lewis is saying, just don't panic. Know this. There's lots going on every day. There's probably, I don't know how many papers are published on neural networks that come, or AI that come out. Every single day there's probably like 10, maybe 100. Most of those will be completely insignificant 6 weeks or 6 months from now. And so to a certain degree, most of the stuff that's happening that seems overwhelming is stuff we actually don't need to know. There's lots of change. There's lots of moving parts. But in the big picture, that stuff's going to go away. And sort of the main ideas of how a neural network works, starting with the very most basic concepts of I'm going to learn, neural networks 101. It's just fits an arbitrary shape to your data. There you go. Everything else is kind of noise after that. Once you learn those real fundamental basics, and sure, you can keep up, and sort of, get more details or whatever. But if you know the fundamental basic, the main idea of neural networks, it fits an arbitrary shape to your data without you having to know in advance what that shape even sort of looks like. You can, that's it. And then you can move on to other things, and you can sort of let all of the noise, all the publications, let that settle. 6 months, a year from now, go back and you can see what's still sticking around, and go, well, people are still using these methods. A year later, let me learn about these methods, and by then you might actually have learned enough about neural networks that you can then um, uh, understand these methods. And the other thing is I mean, I know it sounds bad to be like a year behind the cutting edge, but it's typically years before that stuff really goes into production. It's not like someone produces something and then the next day it's like being used in production at a big major financial institution. It's the transition from cutting edge to used every day is in the order of years. And like we said earlier, a lot of the old methods are still being used for that reason. Um, so to quote Lewis, don't panic. Focus on the main ideas, and just as long as you understand the basics, you're probably good to go.
Yeah, absolutely. And I think there's also a big gap between using and understanding fully.
Yep.
Like I use neural networks a lot without fully understanding, and I was like, okay, if I give data, it
Yep.
puts answers questions, and then you later understand them. Same thing happened with like transformers, right? Let's say
Yep.
it's a big neural network with attention. It
Yep.
took me a while to understand it, but you could use nobody stops you from using ChatGPT or things like that. So I feel like you can get pretty far like using something and then
Yep.
later start understanding, and some things they'll stop being used and then you don't have to worry about understanding that one, so you move to the next one. But yeah, the sentence definitely of the day is don't panic.
Yeah.
um,
Exactly.
yeah. So somebody asked about statistical analysis along these routes, like how much
Yeah.
do you need to know statistical analysis to get good at machine learning, or to get a job at least?
Yeah.
Yeah, and I feel like I know some statistics, not as much. You know a lot more statistics. I feel like some more like intuition. I feel
Yeah.
like probability and statistics intuition is better than knowing a lot of stuff. Like
Yeah.
if I don't know.
I think that's correct. To me, the key is as long as you understand that, like, there's this concept of variation, um, and that you need to keep it in the back of your head that if you did this again, you'd probably get a slightly different result. Um, and as long as you're aware that there's variation and things aren't always the same every single time, I think you're like 95% of the way there. And once you realize there's variation in the output, then you can say, well, is there a lot of variation in the output, or is it just a little bit of variation? And if there's a little bit of variation in the output, your intuition is probably right, right? You can make good decisions based on this, whatever this is. If there's a little bit of variation, then you might make the wrong decision, but it's not going to be that far off. Whereas if there's lots of variation in the output, then you should be a little less confident in the decisions you make based on that data, right? If there's tons of variation, you make a guess, you could be way off. And as long as you understand those things, that you're taking a guess and the variation gives you a sense of how much confidence you should put in that guess, bam, that's great.
Bam. Love it. Yeah. And notice that we never talked about the formula for variation, right? Or the
Exactly right.
properties
Yeah.
or anything, even the notation.
Yeah.
Variation is how far. Like if I throw a dart 100 times and I'm really good at hitting it, there's a little
Yeah.
variation. But if I throw it all over the place, there's a lot of variation. That's all you need to know.
Yeah, we could play darts next time. We'll see
Perfect.
who to trust more in the next game.
Exactly. Let's do it. Who has more variation?
Exactly.
Yeah.
I love it.
Nice.
I absolutely love it.
All
What else we got?
right. Well, there's one that I don't know how to answer, but I will still address it. I have a question about Tesla's end-to-end pipeline. How does Tesla create the 3D ontology model just using camera sensors? So I don't know, but definitely occupancy networks is where you want to go for. I've heard about them, and they're like a kind of 3D version. CNNs do 2D. This is like a 3D thing with
Yeah.
different sensor inputs. That's kind of when you want to, where you want to go. But I one of the many things that I don't
Yeah.
know. So yeah, just wanted to address that one.
Yeah. If we had, yeah, if we
There's
had
one
a
on it.
Tesla employee, we might be able to answer that one a little
Oh,
better.
good. Yeah. Let's see. There's one on F1 score.
Yeah.
Using F1 to measure model performance is by Nosun. Are
Yeah.
false negatives accounted for, and can you give your intuition of when to use F1 score or other alternatives? I can say a little bit if you want to.
Please say something.
Well, I feel like you can have. I like two models, right? Like some of them have recall and some of them have good precision. For example, if I have a spam model, I want a good. I'm probably gonna get them wrong, but I want a good precision because I don't want to get a good email on my spam box, right? I don't mind getting spam email on my inbox, but I don't want a good email on my spam box. So
Yeah.
I don't want, is that a false positive or false negative? I don't want one of them.
Yeah.
And then if I have a medical model, I want the opposite. I don't want to tell a sick person that they're healthy. I
Yeah.
would be able to tell a health person that they're sick,
Yeah.
but not the opposite. So I don't want the opposite, the false negatives or the false positives. And so sometimes I want both. I want a bit of precision, I want a bit of recall. But precision only measures precision and recall only measures recall, whereas F1 score tells me if one of them is low. It kind of
Yeah.
rings a bell, right? It's closer to the minimum. It's not the average, because the average is bad, because if I have too much, if I have really good precision and really bad recall, then the average is high.
Yeah.
But the F1 score kind of goes, it's an average, but it's closer to the minimum.
Yeah.
So it rings a bell. So I always do F1 score because it tells me when when one of them is really low. It's the harmonic mean, actually. The harmonic mean between two numbers is it's not the average, but it's instead of x plus y over 2, it's I think it's 2 divided by 1 over x plus 1 over y. It's an average that if they're the same, it's the same, but if they're different, it's weighted towards the smallest
That's
one. So yeah, definitely always use F1 score. Other alternatives, you can change the one, right?
Yeah.
Like if you want more to precision, do F2, F10. If you want more to recall, do F1 tenth or F1.
Yeah.
And I probably mix them up again. I will always mix those two up.
Yeah.
If I'm put on the spot.
But with
Yeah.
F1, you don't actually, you just need to know that something's off, and
You know that one of them
yeah.
is off, which is what
Yeah.
you need.
And then
right?
you can
Like,
start rummaging around and find out what's going on.
right, but it rings
Yeah.
a bell. Yeah.
Yeah. Lewis, you get another BAM.
I'm getting bams. Nice.
You're
I
just getting
love
so
it.
many BAMs. I think that's fantastic. I love that. I love the way you put it. It rings a bell.
Thank
love
you.
it.
Thank you
Yeah.
very much.
It's perfect.
I love that I'm getting
Yeah.
bams. Okay, there's an easy question, and I don't know if it's for you or for me, but it's
Yeah.
are you planning to translate your book to Spanish?
Which one?
Um,
The the
I
my
don't know.
existing book already has a Spanish translation.
Nice.
The new book, it's possible I'll translate it into Spanish. I'm already working on the Korean translation. The Korean people are just like, there's a publisher in Korea that's like already on it, and they're sending me contracts, and I don't even have the book done. Spanish was harder though. There wasn't a company that wanted to do it, and so I actually did it on my own. I didn't translate it myself. What I did is there was a friend of mine living in Colombia actually,
Oh,
who did the translation just
maybe
one
I'll-
chapter at a time. It took about a year because it wasn't their full time job. They just did the
Yeah.
best they could, and then from that, and from that, I then sent it to a statistics professor at the University of Barcelona, and they went through and they made sure it sort of worked. They were basically the double check, because I can't double check it. And so we did get a Spanish version. It was, I will say, it was very expensive, and I've not yet broken even. and so
Yeah.
and so I'm gonna, if I can find a better way to translate it into Spanish, I would love to. I'm trying to learn Spanish myself. That's my
Well, if I can be
dream.
of any help, if you need a
Yeah,
proofreader in
Louis.
Spanish, I can.
Yeah.
I wonder if